Hi everyone, welcome to our lesson 2.5 on the distributive property. Let's kick off the lesson by first starting with a real-life example using the distributive property. You don't need to copy down the notes, just watch and listen. So suppose that the cost of a snowboard is $90 and a pair of goggles cost $12. If you buy your family, and there are 4 of you, 4 sets of snowboards and goggles, what are 2 ways you can calculate the cost? Well, here is one way. You can take the cost of 1 set of snowboards and goggles, and that is $90 plus $12, and you can multiply that by 4 since there's 4 family members, which totals to $408. Or you can do this following way. You can instead find how much 4 snowboards cost and add that to the cost of 4 goggles, so that would look like 4 times 90 plus 4 times 12, which again gives you the same result of $408. So we have both different computations that give the same result. And note that the 4 from the first problem is basically being distributed as a multiplier to each of the terms in the second way to write an expression for the same problem. Which brings us to the distributive property. So here's where you're going to start writing down into your notes. So the distributive property for all real numbers a, b, and c states that if you have a multiplier a times the sum of 2 terms b and c, then it is equivalent to taking that multiplier and distributing it to each term. So ab plus ac. And this works the other way as well. So if you have the sum of b and c times a, then you can again distribute that a, and that would be ba plus bc. Now this is the distributive property with respect to addition, but we also have the distributive property of multiplication with respect to subtraction. So underneath, if you have a multiplier a times the difference of b and c, then you can distribute that a to each term. So it will be ab minus ac. Same way goes other round. So if you have b minus c first times a, then it will just be ba minus bc. Again, excuse the writing. Sorry if that looks a little messy. Now this is the algebraic way of showing the distributive property, but you can also show it visually, and here is how you can do it with an area model. Here we have 2 rectangles with the same height. Now if I want to find the sum of the areas of these 2 rectangles, I can either find the area of each rectangle and then add those 2 areas to find a common area, or because they have the same height, I can just add their bases or their lengths and then multiply that with the height. And this is how the distributive property looks visually. So here we have separate rectangles, whereas here we combine the rectangles and just use the same multiplier since they have the same height. Make sure to pause at this moment so that you can copy the visual down before we transition into our practice problems. Our first 2 practice problems go into how we can use the distributive property to multiply numbers in our head more easily. So let's say we have a problem that's asking us to multiply 7 times 28. Now traditionally people might just think 8 times 7, carry it over, then multiply 7 and 2. Whereas if you split the number 28 into a sum, into 20 and 8, you can multiply 7 times 20, then add your product from that to 7 times 8, which gives you 140 plus 56 is 196. Same thing works with fractions. If I wanted to multiply 12 times 2 and 5/6, instead of changing this fraction, this mixed number, to an improper fraction, I can split up that 2 and 5/6 into 2 and then 5/6, so it's going to be 12 times 2 plus 12 times 5/6. So in my head, all right, well 12 times 2 is 24, and 12 times 5/6, if I cross simplify, that's just going to be 10. So 24 plus 10 is 34. Versus Again, changing this to improper and then multiplying across and simplifying from there. Before we move on, I want to point out a common error that I've seen over the years. People will try to use the distributive property when it is multiplication with multiplication. So for example, let's say you had 3 times 4, and then inside the parentheses it's 4 times 6. So people will try to distribute and think, oh, okay, well that's just 3 times 4 plus 3 times 6, and that's going to give me an answer of 12 plus 18, which is 30. Or people might try to do this. They might think that I can rewrite this as 3 times 4 times 3 times 6, which equals 12 times 18, and 12 times 18 is 216. Both of these are incorrect. They are wrong. So when you have multiplication, you just multiply across, because the real answer is, if you were just following order of operations, 4 times 6 is 24, and 3 times 24 is actually 72. So make sure that when you use the distributive property, it's a sum inside or a difference, not multiplication. So go ahead and write that as a common error in this space right here. What mistake do people usually make? Before giving you your last practice problems, I wanted to give you a corny math riddle just to make sure that you're watching. And it says, how do you make 7 even? Anyone? Well, to make 7 even, if you take out the s, it is even. Oh, all right, moving on. So practice problem number 3, we have 4 times 53. And what I want you to do is, in your notes and also in the form, explain how you can rearrange or rewrite this expression so that you can do the mental math more efficiently. And if you need to, look back to practice problems numbers 1 and 2 so that you can have an example of what I mean. Same thing with this second one. If you have 30 times 18 plus 70 times 18, how can you rewrite this expression so that you can, again, do the mental math more efficiently in your head? So go ahead and write your responses for those two in the form. And for the last 2 practice problems, I just want you to simplify each of these expressions. So for the first one, we have 5n plus 7 times the difference of n and 3. And for the second one, we have the difference of y and 5 times 6 increased by 15. If you have any questions at all, please make sure you write those down in your notes so that we can discuss them in class on Monday, and we will review the answers and any confusions or questions that you may have. Have a good weekend. See you Monday.